Hey, Dr. Clark coming back at you with another differential equations video. This time we're doing a check your understanding on section 3.1. That section is all about modeling. So let's take a look here at the problem they've given us. We have a patient given a particular medicine via IV, constant rate of 10 milligrams per minute. The body metabolizes the amount present in the body at a rate proportional to the amount present, which they're calling A of t, and they give a proportionality constant of 0.2. How many milligrams of medicine is in the patient at time t equals 120? Okay, so A is the amount, so if we write ourselves a differential equation, it's going to be dA dt. It says it's metabolizing the amount that is present, and the amount present would be A. So if it's proportional, that's minus Ka, right? That's removing the amount proportional to the amount, and they give us the constant is 0.2, which I'm going to write as 1/5. So I'm going to put this as negative 1/5 A. But then we are also adding 10 milligrams per minute in, so that's just a constant forcing term of 10. And there is our model. So I think that's the main part of the lesson, is to be able to sort of construct these models. A good model would be the differential equation plus the initial condition. They didn't really specify, so I'm just going to assume that there's no medicine present at time 0, and then the body sort of ramps up. If they were more specific about the initial condition, I think it would be given more precisely. So that's a model, a differential equation plus an initial condition. And then in order to know how much medicine is at time t equals 120, we're going to have to solve this differential equation. It looks like it is a linear differential equation. And in chapter 2, we learned how to solve linear differential equations like this using the method of integrating factors. We take a look at that term that's adjacent to the A, and the integrating factor is e to the integral of that term, which is 1/5, and the antiderivative of 1/5 is just 1/5 t, so it's integrating factor e to the 1/5 t. So I'm going to multiply through e to the 1/5 t times the entire differential equation. And it's very easy to forget to multiply right-hand side by the integrating factor, so don't make that mistake. And now, if we've done this correctly, it should be the case that we can think of this as sort of f g prime plus f prime g, which is a product rule, and the integral of a product rule is the product fg. And you can see there's f and f prime, and there's g and g prime right there. So we have the structure that we've learned about in chapter 2. So I'm just going to integrate both sides using that method of integrating factors. And so we're going to just get f times g, which is e to the 1/5 t, a of t equals the antiderivative of 10 e to the 1/5 t, I guess dt. I think that's going to be 50 e to the 1/5 t plus constant. Yeah, because if you differentiate that, you get the 10. And then we divide both sides by e to the 1/5 t in order to get the function a that we're looking for. And I'm going to write that as c e to the minus 1/5 t, because dividing by e to the 1/5 is the same as multiplying by e to the minus 1/5. So this is my general solution. If we include the initial condition, we can get a specific solution, which I think we can just set c equal to 50, because when t is 0, e to the 0 is 1, and then we'll just get basically 50 minus 50 is 0. So this will satisfy the initial condition, a of 0 equals 0. And you can see we have this right here, this transient term So if you're thinking, what would the graph of this function look like? It's going to start at 0, and then it's going to level off at 50 as the transient term sort of goes to 0. And they want to know after 120 minutes how many milligrams of medicine is in the body, and that's A of 120. So that's the original question up here. It just says at t equals 120, how many milligrams are present? So that's A of 120. I would just get 50 minus 50 e to the negative 120 over 5. You can leave it in exact form, or if you like, you could use a calculator. Let me just type this in. And I am getting basically 50. So this term is essentially 0, and so the transient term is basically 0, and so you essentially just get exactly 50. All right, and that is how you would solve that problem right there. So make sure you give yourself some reflection comments, thinking about, did this problem make sense? Were you able to do the solving? Were you able to write the model down correctly? And then give yourself a grade so you can have a sense of how well you're coming to understand the modeling and the solving in section 3.1. All right, we'll see you next time.